I just thought about this fine integral for you guys. And for this one, you can really solve it within 5 seconds if solving integrals is your second nature. And I think some of you guys might see this already. The answer is just equal to x squared times sine of 1 over x. And of course, don't forget the plus c. Why? Because if you differentiate this, you get that, keep the second, and then if you keep the, this is really, keep the first and, well, let me verify that with you guys. Yeah, in fact, it's just going to be differentiating this, and we have to use the product rule, and we will get this result. But let me write it down. I'm going to use this version of the product rule. I will differentiate the first and keep the second. And then I'm going to keep the first now because I haven't kept this yet. And then I'm going to differentiate this. Differentiating sine, we get cosine, and the input stays the same. And then we have to use the chain rule, and the derivative of 1 over x, which is the same as x to a negative 1. Bring that to the front, minus 1, negative x to a negative 2, which we can multiply by negative 1 over x squared. And it just happened that x squared and x squared cancel. Well, it's not just happened, it's like, well, I meant it like this, and then anyways. Put a negative right here, and you get exactly what we have. Done. And now you might be wondering, is there a more legitimate way to solve this? Yes. Now, the idea is that if an integral, like the integrand inside, it's a result from a product rule, then you can actually just do integration by parts. Let me show you. So what I'm going to do is, I'm going to break this down into two integrals, 2x times sine of 1 over x, and then close that, and then minus the integral of cosine of 1 over x, and then dx. I am going to start with this term right here and do integration by parts. And in fact, the 2 right here is crucial. Without the 2, the result is not going to be elementary. But anyways, I am going to be using the DI setup, right, or DI method. And I will have to think about what to integrate and what to differentiate. If I put sine of 1 over x to be integrated, no hope. I really have to differentiate sine of 1 over x. That means I will be integrating to x. And that is easy to do. We just get x squared. And to differentiating, well, you can always differentiate, except for some special functions that is nowhere differentiable. But for this, you can just differentiate cosine of 1 over x times the derivative of this, which is what we went over earlier, right? Negative 1 over x squared. So take this times that, we will first get x squared times that. And this is the first part of the answer, no more integral. However, you see that this right here still have something, right? So I'm going to multiply this row and then put that inside of integral. Here's a minus, but here's another minus, so that's a plus. And then if you put them inside of the integral, well, this and that cancel, we really just have cosine of 1 over x. This is outside of the cosine function, right? So yeah, this cancels out with that. Okay, and guess what? If you bring this down, minus integral cosine of 1 over x, it just happens to be that they cancel each other out. So you don't get any like non-elementary functions. So the final answer is x squared times sine of 1 over x plus c.